All right, so we can draw Lewis structures, and then what some of you are finding as you're drawing Lewis structures is there's more than one way to make it work. So let's say we have silicon dioxide, which you see here in this diagram, and structure A and structure B, if you count all the electrons, 2, 4, 6, 8, 10, 12, 14, 16, 2, 4, 6, 8, 10, 12, 14, 16, all have 16 electrons, all right? So they're accurate. They have the correct number of electrons. Um, is each a legitimate structure? And the answer, of course, is yes. And we know that because oxygen has 8 electrons, silicon has 8, oxygen has 8, this oxygen has 8, silicon has 8, this oxygen has 8. So they're legitimate structures. So both of the silicon bonds are identical, is what we have found out from science, okay, from doing experiments. So if these bonds are identical, obviously structure A is correct. So A is correct because they both can contain 2 double bonds, while B has a single and a triple bond. All right, so now, but there's an easier way to do this as opposed to having to run experiments like we did here. And we can do something called finding formal charges. So when there are 2 structures that are possible, we use formal charges. And so let's look at structure B for SiO2 and find the formal charge. So let's look at this oxygen first. And it has 2, 4, 6 unshared electrons and 1 shared. So it has 7 what we call formal electrons. If we take valence electrons minus formal, oxygen has 6 valence minus formal, we get a -1 charge. Silicon then, let's look at this one, has 1, 2, 3, 4 formal electrons, and silicon has 4 valence electrons. So silicon's 0, we're okay. This oxygen, all right, has 6 valence electrons. Let's count its formal, 1, 2, and then these 3, 5. So 6 minus 5 is +1. So we go -1, 0, +1. Charges together equal 0, but we have a formal charge. So these oxygen 1, oxygen 2 have a charge to them, have a formal charge to them, which we don't want. So if we don't have a formal charge, then we want to make sure that it's 0 in structure A. So let's look at structure A. Oxygen has 2, 4, 6, 2, 4, 5, 6. 6 minus 6 is 0. Silicon's still 0. This oxygen, 1, 2, 3, 4, 5, 6. 6 minus 6 is 0. All zeros. Structure A is better because it has no formal charge in any of the atoms. Okay? So if 2 different structures are possible, does the best structure have the fewest or most formal charges? Has the fewest. And now we're going to do examples 6, 7, 8, 9, and 10 on the board. Do them now. All right, so we want to draw the Lewis structure for carbonate. And to do that, we will put it here. So we got CO3, 2 negative. I have a carbon and 3 oxygens. Carbon has, when I look at valence electrons, has 4. Oxygens have 6. So 12 plus 10 is 22 as a -2 charge, so I add those 2 electrons. So I should have 24 electrons in my structure. I'll put carbon in the middle because it's by itself, and I'll surround it with oxygens. So there's my skeleton. Now I add here, so I can get 8 electrons around all my oxygens. Now I'll add them all up. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So I have 24. I don't want to add any more electrons. But my carbon only has 6 electrons around it, and or 6 electrons, and it wants 8. So what's going to happen is I'm going to make a double bond here, okay? And remember, I got to bracket it, and that double bond could be here or here. So I'm going to have a couple of different structures here for carbonate. draw my Lewis structures for carbonate. And now we want to find the formal charge of each atom. I'm just going to pick this one down here. All right. So oxygen has 6. So the formal charge is 1, 2, 3, 4, 5, 6. Right. So the equation, just to review, the equation is number of valence electrons minus formal electrons. So oxygen has valence electrons of 6. 1, 2, 3, 4, 5, 6. Minus 6. 0. This oxygen has 1, 2, 3, 4, 5, 6, 7. So 6 minus 7 is negative 1. This oxygen has 6 valence electrons and 2, 4, 6, 7 for negative 1. And then this one has, this carbon has 1, 2 has 4 valence electrons and a formal charge of 4. It goes to 0. So I look at carbonate, 0, negative 1, negative 1, 0. And so that's the formal charge would be negative 2, which you can see matches the charge of my ion. So we expect our formal charge to match the charge of our ion. And if you were to find the formal charge of each of these structures, it would be the same. So which of these structures is accurate? They all are the same. Any one of these can show up, and that's why we draw valence electron, or not valence, but structures that are resonance, so that we can see that, okay? So now we want to draw a Lewis structure for ammonium and label the formal charge of each atom. So ammonium. So ammonium is NH4 positive, and there's 4 H's. Right? Nitrogen has 5 valence electrons. Each hydrogen has 1, 5, 6, 7, 8, 9. Has a positive charge, so I subtract 1. So I should have 8 electrons in my structure. Since hydrogen can't be in the middle, my nitrogen's in the middle. And I get this. There's my skeleton, count 2, 4, 6, 8. 8. My hydrogen each has 1 bond, which it wants. Nitrogen each has 4 bonds, which it wants. This is my Lewis structure. Now let's find formal charge. So each hydrogen, right, has 1 valence electron and has a formal charge of 1. So net formal charge is 0, or formal electron 1, net formal charge is 0. Nitrogen has 5 valence electrons, and it has a formal charge in this case, or formal electrons of 4. So I go 5 minus 4, which equals 1. Again, my 1 matches my charge. Obviously, this is the only structure. There are no others, so I don't have to use formal charge to find structure, but I can see that this is for sure accurate. Now let's look at SO3 and find the formal charge of all these. SO3 no charge, right? So I got sulfur and 3 oxygen. Sulfur has 6 valence electrons, as does each oxygen, for 24 total electrons. Since sulfur's by itself, I'll put it in the middle and surround it with oxygens. Okay, I'll dot these up. Then count them, 2, 4, 6, 8, 16, 18, 20, 22, 24. I got my numbers. Sulfur only has 6 around, so I have to make a double bond. And that double bond can go here, it can go here, it can go here. So I could draw all these structures. So I'm not going to. I just want to find the formal charge of each atom. So I'm going to call this 1, 2, and 3 oxygens. So oxygen 1, right? Oxygen 1. And we look at oxygen 1, and it has 6 valence electrons, minus 2, 4, 6, 7, makes it negative 1. Oxygen 2 has 6 valence electrons, 2, 4, 6, 7, for negative 1. Oxygen 3 has 6 valence electrons, 2, 4, 5, 6, for a formal charge of 0. And then sulfur has 6 valence electrons, 1, 2, 3, 4, for positive 2. Positive 2, negative 1 should be no charge. There is no charge. If I move the double bonds to different spots, we'll get the same answers, just different electrons will have different charges. But again, no structure's exactly right for this one. And then all right, so we've done them. So a few things to fill out with these charts. So the sum of the formal charges for all the atoms and structures are always equal the charge of the molecule or ion. For example, the charge on carbonate is -2, and the sum of the formal charges also is -2. And now we're going to do number 13. Which of the following best describes the structure of this? And we're going to do that one on the board. Do it now. Now, let's look at number 13 there. And number 13 says we got CH2O2 in different structures. So I got C, double bond O, H, O, H, right? And I have these electrons, and then I have CO, H, O, H. Now my double bond's here. So it's a double bond here, double bond here, and that's what we're going to try to figure out. So we're going to look at formal charges to see if we can come up with the best structure. So let's look here. This hydrogen, right, I'm going to call this 1 and 2, 1 and 2. So H1 has one valence electron and one formal electron, charge is 0. H2 is also 1 minus 1. O1 has 6 valence electrons and 1, 2, 3, 4, 5, 6, which is 0. O2 is 2, 4, 5, 6, minus 6 is 0. And my carbon has 4 valence electrons and 1, 2, 3, 4, 0. So no formal charges here, and my net charge is 0, so that's good. So now let's look here. H1, H2, O1, O2. H1, 1 valence electron, 1 formal electron, 0. H2, 1 valence electron minus 1 formal electron, 0. O1 has 6 valence electrons, and I have 2, 4, 6, 7 formal electrons for a -1 charge. O2 has 6 valence electrons, and then 1, 2, 3, 4, 5 for a +1 charge. And then my carbon has 4 valence, and then 1, 2, 3, 4 formal for 0. So net charge is still 0, but since I see a charge here and no charge here, this is a better structure because all the formal charges are 0 individually as opposed to having a charge. So that's why I choose that one.